Hey, this video is on significant figures. I'll tell you in AP Chem, in the AP test, they want every answer put into the correct number of significant figures. So significant figures is just basically looking at your instrument you're measuring using. You always estimate to one digit beyond what the instrument measures to. So if the instrument measures to the nearest 0.1 of a milliliter, you would measure to the 0.01. You can estimate one digit beyond, which we'll do a little bit of in class. But this is just a way to make sure that you're not adding in too many digits to your answers, that really you're just making up precision in that situation. So our answer can't be any more precise than the instruments we are using. So the rules will seem a little bit strange in certain situations, but they're not too hard to determine. So I'm going to kind of skip here, but here is kind of the rules for significant figures, or Sig Figs as we call them in class. First thing, all non-zero digits are significant. So anything that's not a zero in a number, so a 1, a 5, and a 1, 5, and a 3, anything that's not a zero is significant. That's pretty easy. So obviously count as digits. Zeros between non-zero digits. So if you have any zeros between, for example, that zero right there is between two non-zeros, those count. So everything that's not a zero, any zeros between, like this one right here, is between two non-zeros. So those count. Those are two pretty easy rules. Zeros beyond the decimal point at the end of a number are significant. So here's any zeros at the end of a number. Zeros after a decimal are significant. So what that is telling you, say this is measuring in centimeters, 15.0 centimeters. That tells you this instrument is measuring to the nearest 0.1. Okay. If that zero is not there, if it's just 15, that would tell me the instrument was measuring to the nearest whole number. So this is telling you the precision of the instrument. By putting that zero in there, it's saying, okay, I know it's not 15.1. I know it's not 14.9. It's exactly at 15.0. So that's why that's significant. So zeros at the end are significant after the decimal. Zeros after the decimal. All right. Zeros preceding the first non-zero. So zeros at the beginning. So if you have a decimal, zeros at the beginning are not significant. Those are just placeholders. I'll explain a little bit of that here in a little bit. So here's kind of an easier rule. If you look at zeros at the beginning or at the end, so zero at the beginning never count. Zeros at the end after your last real digit, zeros after your last real digit count as long as there's a decimal. So zeros count as long as there's a decimal. So for example, that counts. If you would see, this is weird, but if you would see that, if you see a decimal in there, a zero after your last real number counts as long as there's a decimal somewhere. I don't care where the decimal's at. So if we'd have 0.001400. Zeros before never count. Zeros at the end count as long as there's a decimal. Doesn't matter if that decimal's after the zero, out in front. Trailing zeros count as long as there's a decimal. So it's telling you that instrument is measuring out to those places out there. This one is telling you, by this zero being here, is telling you they're measuring to the nearest whole number. It's exactly 150. Okay, it's not 149. It's not 151. It's right there. That instrument measures to there. All right. So if you're trying to figure out sig figs, number of sig figs in this, there are 4 sig figs. All of them count. The zero in the middle counts. This one, there is no decimal, so only this and this are significant digits. There's only 2 sig figs in that number. Here. 3 sig figs. Again, zeros at the end count. Zeros at the end only count if there's a decimal. No decimal there, so just 2 sig figs. Zeros at the beginning do not count. They're just placeholders. 1, 2, 3, 4. 4 sig figs. All right. Sign notation. This is scientific notation. So something times 10 to a power, which you're going to see a lot of this year. Everything here is considered a significant digit. So this would have 3 sig figs. If we had like 4.300 times 10 to the 8th power, whatever is there is significant. So there would be 4 sig figs in that. Okay. So an easy way to do this is to put numbers in scientific notation. If we put this in scientific notation, it'd be 1.5 times 10 to the 3rd power. Well, there's 2 sig figs there, 2 sig figs in that. Okay. This one you'd go 1.50 times 10 to the 1st power, 3 sig figs. So whatever's there in scientific notation counts. All right. Multiplying, dividing, which is about all we do in this class. It's very little addition, subtraction. Multiplying, dividing, your answer cannot have any more sig figs than the quantity with the least number of sig figs to start with. So if we're multiplying these two numbers, there are 1, 2, 3, 4, 5 sig figs in this one. 1, 2, 3, 4 sig figs in that one. Our answer can only have 4 sig figs. So we would need to round to where there were 4 sig figs. So if we multiply those two, you actually end up with, let's skip and go to the next one. Okay. This one, if you're multiplying this by this has got 3 sig figs, this has got 5, so our answer could only have 3 sig figs in it. So when you multiply these two numbers, you actually get an answer of 10,760.45. 10,760.45. This must be 6. Well, 3 sig figs is the least number of sig figs in the numbers we're multiplying, so our answer has to round to 3 sig figs. So there's 1. There's 0 counts because it's between 2 of them. There's 2. There's our third sig fig. So we need to round to that, which the 7 rounds to an 8. These become 0. So 10,800, which has 1, 2, 3 sig figs in it. All right. This one, if we're dividing this, which has 6 sig figs, by this, which has 3 sig figs, our answer needs to have 3 significant figures. So this might have come out to be like 8.95943. Well, 1, 2, we need to round to the third digits. This becomes a 6. Those are gone. That'd be our 3 sig figs. So multiplication, division, round to the least number of sig figs in the numbers we're multiplying or dividing. Addition, subtraction is a little bit different. We don't do a lot of addition, subtraction, but it's a little bit differently. Addition, subtraction would be this rule. You cannot have any more sig figs than the least significant digit in your problem. Sorry. So when they're subtracted, the number of digits beyond the decimal point in the result, in your final answer, is the same as that in the quantity with the smallest number of digits beyond the decimal point. So if we're adding these 3 together right here, this has got 1 digit beyond the decimal point, so we're not worried about sig figs here. We're worried about decimal points. This has got 2 digits after the decimal point. That's got 4. This has the least 1 digit beyond the decimal point, so our answer has to have 1 digit beyond the decimal point. So if we add those up, I don't know if I have this on the sheet. If we add those up, you end up with, about 183. I don't know if it's 0.6 or 0.7, one of those two. We can only have 1 digit beyond the decimal point. So we get rid of any others beyond there, round to that spot right there, because this only has 1 digit beyond the decimal point. Not a lot of times. We're usually multiplying or dividing. Okay, usually multiplying or dividing. So quick rules again for sig figs. We're always worried about zeros. Zeros at the beginning of a number. At the beginning, never count. Zeros at the end count as long as there's a decimal. Zeros at the end count as long as there's a decimal. I don't care where the decimal's at, but those zeros count as long as there's a decimal, showing you the precision of the instrument. One more quick thing here. This is kind of important. I should have shown this here earlier. Let's say we have these numbers, 1,500 millimeters, 150 centimeters. That's 1.5 meters, 0.0015 kilometers. These are all the exact same distance. Okay, it's a meter stick and a half. All of these are a meter stick and a half. They're the exact same distance. If we look at our sig figs, 2 sig figs, 2 sig figs, 2 sig figs, 2 sig figs. Okay, they're the exact same measurement. They all have 2 significant figures in them as well.